Hello, in this video we'll be talking about our previous three milestones as well as our special component milestone. In milestone 1, which was the build phase, we had set up two branches and we had set up a webhook which would trigger a Jenkins build job corresponding to any commit made on GitHub. And these were the two Jenkins build jobs, and for each build status, whether a success or a failure, and a corresponding email was sent out to the developer, as you can see over here. In milestone 2, which was the test and analysis phase, we had used a Java project and we had the similar webhook structure in place. For our test gate, we had used Rundoop for increasing our coverage, and the static analysis was done using FindBugs tool. We had used Kobuchura and Violations, which were Jenkins plugins, for displaying the reports. This is the Kobuchura coverage report for our project, and after running Rundoop, you can see that the coverage has increased from 33% to 56%. This is our FindBugs web page, and this includes our custom FindBugs warning rule which we had set up, which shows all the warnings in each of the files in the package. Now we had also set up a threshold value which would reject any build if the coverage was below this threshold or if the FindBugs warnings were above this threshold. And on each case, an email was sent out to the developer, as can be seen over here. Here we had set those threshold values. In milestone 3, which was the deploy phase, we had used our Python Flask application from milestone 1, and we had set up a production and a canary branch for this, and we had again set up a webhook structure which would trigger a Jenkins build job based on any commit made to GitHub. Now, for deploying our instances onto the production environment, we had used the Amazon Web Services code deploy plugin, which would zip the software artifacts and deploy it onto an S3 bucket, which would then perform a sequence of steps and load it onto the production environment. Configuration management was done using Ansible, and this is the playbook that we had used. After the configuration management was successful, we get this message. And these were our two Jenkins build jobs corresponding to Canary and our normal production branch. And after the test and analysis gate completed, these were the artifacts that were now deployed onto the S3 buckets. And once the deployment succeeded, we could go to the IP address and see the task in action. As you can see, the font is red. This was due to our feature flag functionality. When we set that feature flag off, you'll see that the font is black now. We had also set up a monitoring server for checking the memory and CPU metrics for our production environment instances. For our special milestone, we are now making use of a decoy monkey. The purpose behind using a decoy monkey is to prevent an web server from being inundated with DDoS attacks. What this decoy monkey will do is, when the web server is subjected to a DDoS attack, this decoy monkey will be called into action. It will take all such DDoS requests onto itself while leaving all the normal requests for the web server. Now, we have added one more functionality on top of this. To prevent some legitimate user from being classified as a DDoS attacker and to distinguish between users and bots, our decoy monkey will be presenting a simple CAPTCHA challenge to the attacker. Now, if the user at the other end can successfully solve this CAPTCHA challenge, which will be something very simple like what is 2 plus 2, then we would allow access to the application to that attacker. Now I'll show this in action. I have my main web server and the decoy instance running. I'll go to the website and I'll try to access my application, which is a Python Web Flask application. And for this video, what we are doing is we are setting a threshold value. So we have a sliding window of time in which we'll be measuring the number of requests coming from one instance, and if it exceeds a certain threshold, then we'll redirect it to the decoy monkey. For this video, we have our threshold value as 10 seconds, and the number of requests that can be sent in those 10 seconds is 2. So like you can see, I've sent one request and this is logged over here. When I send one more, this is again logged over here. Now when I try to send one more, this will redirect me to the decoy instance, which is over here. Now I'll be asked to solve this challenge if I'm a user, and if I'm a bot, then I would not be able to succeed. So if I click on no, or if I give a wrong answer, if I don't answer, then nothing will happen. This is when the decoy instance is in action. But when I click on yes, I'm redirected back to the application. So the ideology behind this is to prevent some legitimate user whose requests might have crossed some threshold value from being wrongly prevented from using the application. Thank you.